Okay, full screen here. In a moment, I'm going to show you a couple of graphs superimposed on one another. And I'm going to ask you to tell me what you get when you divide one graph by the other. And I don't want to show it to you yet because I want you to only think about it when I show it to you for about 5-10 seconds and then stop. All right, because I got a particular way I want you to think about it. All right, but you let your mind go wherever it goes, and then we'll stop and talk about um, what you might be looking at. All right, so here are the two graphs. One's in the numerator, one's in the denominator, and I'll show you which is which in the numerator and which is which in the denominator. And you tell me what you would get if you divided the numerator by the denominator graph. All right, so there we have it. The denominator is the cup shape, and the numerator is the line. And what will you get if you divide this graph by that graph? All right, where'd your mind take you? Did your mind try to label what these curves were so that you could work symbolically? Because I don't want you doing that. I want you just looking at it, not applying any names to the graphs, and figuring out what the graph's going to look like. So try to do that, right? Try to stay out of the symbolic world and just go to the visualization and see if you can figure out a couple of data points, and spend as much time as you want, but at least try to figure out, geez, I know that this graph does this here. Okay. Now I'm going to keep talking and going to go through what I'm hoping you may have arrived at as a thought process. So this axis I'm going to call pick a number axis. Pick a number and calculate with it. Okay, so I'll just pick a number for you right here. I'm going to pick this number right there. I have no idea what it is, but what would you get if you divided the numerator by the denominator? And you always pause the video when I ask a question. So what we really have is a function in terms of x divided by another function in terms of x. We commonly refer to those as y1 and y2. And I'm calculating with x over here. And I'm calculating with x over here. And I'm dividing those calculations, which implies that I'm dividing y1 with y2. Now, what is y? Y is a vertical distance from the x-axis to represent the answer you get when you put a number in. We call it x, really just picking a number on the x-axis and working with it. And if I work with it, y1 is this altitude, and it's positive. Y2 is this altitude, and it's negative. Well, this altitude here appears to me to be about, I don't know, 10 times bigger in magnitude than this. I think I'm going to get an answer near maybe minus 1/10. I think I'm going to get an answer right there. A small negative fraction. Okay. I can immediately go to the denominator and say, well, what's that y value? That y value is 0. I don't care what y1 is. If I divide by 0, it's undefined. So I think I'm going to get one of these dotted lines, and I will call it some critical x value. And I think that happens over here as well. I think that's 0 for a y. So my y1 minus my y2 right here, y2 is 0. I have another undefined moment. Now, when we're done, another critical number. I have another critical number. We'll name it. We're going to name these curves later so that you get a feel for we graph and y. Now, as I move to the right, my numerator keeps getting bigger and bigger, and so does my denominator. But my denominator, oh my God, it's getting much bigger, faster. Oh, Lord, what a difference. I can't even keep up with this. So what's happening? Well, I've got a y value here, and I'm dividing it into the y value up there. And the further I go to the right, the bigger the ratio. My denominator is getting huge. My y is going up at a constant rate. Not my curvature. No, that's not going up at a constant rate. I don't think I'm going to get a fraction like this. How many times does that fit into that? I don't think much at all. So I'm going to go out here. And, I think that's actually heading to 0. Now, what happens when I divide right there? Because they have the same altitude. y1 equals y2. I think I'm going to get 1. I'm going to erase that. I think I'm going to get 1. Now, I don't know where I want to say 1 is because I don't have any numbers here. But as soon as I put this on the board, I've got a scale. So I got to be careful here. I'm going to say that is, because I do have about that distance. Because I do know what I'm going to call these in a little while. So that is a y value of 1. This is a y value approaching. Why don't I put an arrow there? 0. Now, let's get to this undefined moment. Let's get rid of some of the stuff I don't need. I don't need that arrow anymore. I don't need to show that. Okay. What happens to my y value? I know it's 0 there. So what is it when it's really close to 0? Well, that's 1. That height, why don't I call that height a y value of 0.01? How many times is it going to fit into something just a little bit bigger than 1? How many times is 0.01, which is positive? That's still above. I'm above the x-axis. How many times is that going to go into 1.5, for instance? Well, I think I've got to move the decimal 1, 2, 3, 4 places, huh? I mean, I'm going to get stuff like this. Eventually, I could really, really get, whoa, numbers like that. And if I divide that, I went the wrong way with my decimals. Sorry. I'm going to get numbers like this. Not going to do the video again. But I think I'm headed towards positive infinity. And somebody's calling me. Let's see who it is. Don't know. Won't answer it. All right. So I'm eventually heading up there. So that's going to be on my graph. That's going to be on my graph. That's going to be on my graph. Yeah, we'll connect those dots in a little while. And what happens right with that number just to the left of 0? What's my y value here? Well, I'll give you a y value that you can see, right? But I'm getting closer and closer to 0. My negative number is getting smaller and smaller and smaller. I'm going to get a negative 0.00001 at some point. And that's going to, be divided into, say, a number like 1. Well, that's going to go in lots of times with a negative. I think instead of going to positive infinity, I think at this instance, I'm going to negative infinity. And then the numerator is 0. The denominator is some significant y value down here, all right? But it doesn't matter what this y value is. If I divide it into 0, my graph passes through there. Then it's interesting to go to the y-axis because, we've got an actual negative quantity divided by a bigger negative quantity. We have this negative quantity divided by this negative quantity. Well, that's going to go in a fractional amount of times. So there's no doubt about that. That's going to be a negative into a negative, right? So a negative into a negative. It's going to be a small positive number. My graph should go through there. And then we get one of those moments again where I'm getting a smaller and smaller denominator y value, but it's negative below the x-axis, and that's dividing into that y value, which is much bigger. So I'm going to get something that has a small negative length. I'll put the negative in front, but I don't want it to look like -1. A small negative amount. All right, how small do we want it? Well, 0.01 again, because as I move to the left, all these negatives are getting smaller and smaller and smaller. And I'm dividing into something that, well, looks to be about -3. Woo, sure looks like it's going to positive infinity again, way up here. And then we get a sign change. As soon as I get on the other side, now I'm talking about I'm above, just above the x-axis. So that becomes positive. Now that y value is not changing much at all. It's still around -3. All right, so how many times? Oh, I get a sign change going to negative infinity. And then I've got this really big numbers, big y values going into something much smaller. Huge positives divided into some much smaller negative. I mean, much smaller. But a negative into a positive is a negative, and I think I'm heading to 0. All right, now I'm going to erase everything except the dots. We're going to see what our graph looks like when I connect the dots. And then we'll do it symbolically. And we'll see if the graph takes on more meaning. Oh, I can get rid of the curves too. Clean enough to look at it from a symbolic standpoint now? Oh, no, I've got all kinds of things still in the way, huh? Yeah, I'll get rid of the graphs. Okay, sure looks to me like it looks like this over here. I think I erased negative infinity here. Looks to me like it looks like this over here. And it looks like that over here. All right, so now let's take Rene the cart, which isn't here. So it's Jim the walker. At least I'm not pushing one quite yet. That's coming. All right, so I tried to mimic, I wrote it down somewhere. What does the graph of x minus 4 over x squared minus 4x minus 12, what does that graph look like? Well, the first thing we have to do is pick a number, and the easiest number to pick is 0. So I get positive 1/3. 0 gets me positive 1/3. Very useful after you get your y-intercept to put it into graphing form, which was x minus 6 times x plus 2. Oh, critical numbers. Add x equals 6. Can you see all of that? Yep. And x equals -2. Let's see, if that's 6 units, I'd say that's about 2. Right about there. Hope that's drawn to scale okay. And you can see that. I'll put it down just a little bit more. Now, it's also good to look at it from the context of exponents. X squared minus 4x minus 12. And I hope you've been doing these enough now to start seeing the pattern of going up a lot faster than this one. And so that's going to 0 without having to put any numbers in. If that exponent's bigger than that one, it's going to 0. If the exponents were the same, 5/3, if they're the same, it's going to go to 5/3. But as soon as that one is smaller than that one, it's going to go to 0. So look for that pattern. Same thing over here. We know that when x is 4, if that's 6, 4 is about there, we have an x-intercept. We know if we put numbers in like 6.01 right there, oh, 6 plus 2 is 8. I'm going to get a number like 0.08. I'm going to get numbers like that. That's if I put number like 6 in here, I'm close to 2. That number into 2, whoa, a lot of times it's going to positive infinity. So I now know my graph looks like that. And if I make this thing 5.99999, I get a sign change and it goes to negative infinity. That's what you're trying to learn. Well, I can see that same thing's going to happen over here. All right, and we're going to get a sign change. And you can verify these things by picking a number like, how about -5? -5 should get us a, fairly small negative number, certainly nothing that's close to negative infinity. So let's put -5 in. That's -9. -11 times -3, positive 33. There's your small negative number. If you had some graph paper, you could do justice to the cause. All right, so I'm going to ask you, it's going to become a daily quiz. You'll be graphing that for me. Well, actually, something like it. Going to be very close to this. That way I'll know if you looked at the video or not. Well, maybe I won't know because some of you know how to graph these well now. I'll think about it. We'll figure out what to do with this. Right now, we're just going to call it a graphical exercise. That's what it is. And I'll ask you some limit questions over here. We'll call this function f of x. The limit of f of x as x approaches infinity is equal to what? Now remember what another name for f of x is. The limit of y values as x goes to infinity. Do you have a feeling for the y values when you put big, big numbers in? Hopefully that explains that. Now remember, I'm going to write f of x, but you think y. What's the limit as x goes to 6 from the right of f of x? As we move to 6 from numbers bigger than 6. Well, here's 6. Here's numbers bigger than 6. I'm going to move my finger towards 6. Where's my hand going? Positive infinity. Okay, I can erase here and just keep the questions coming. How about the limit as x goes to 0 of f of x? Well, it's all about the y values I'm heading towards. Let's go at it from both directions. Boom, 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 boom. I'm moving towards 0 from both directions. I think I'm heading to a value of 1/3. Nothing too exciting about that limit. How about if I go to 6 from the left? Can you tell me something about my y values as I move to the number 6? I'm picking x's now. I'm picking x's. 6 with a minus sign means I'm picking a 1. I'm moving to 2. I'm moving to 5. I'm moving to 5.5. I'm moving to 5.999999999. What's happening to my y values? Woo, they're going to negative infinity. As I move closer, my y values are going to negative infinity. Well, how about as I go to 6? Because that means I'm coming in from, remember, those are arrows, not negative numbers. I'm heading to 6. Well, that means I'm going from 7 to 6.5 to 6.0. And we did that. We're going to positive infinity from the right, negative infinity from the left. If they're not the same y value, then you can't tell me much. So right does not exist. How about as my x's go to negative infinity? You're picking numbers on the x-axis. I'm trying to go to negative infinity, I guess. Oh, seems like my y values are heading to 0 as well. Okay, so hopefully that's starting to make more sense than it did a week ago. I know it is for a lot of you because a lot of you are writing those answers down very quickly now. And I'd like to see everybody write those answers down very quickly. All right, so there's a little graphical exercise, which means that if you can picture graphs like, you know what e to the x looks like, and you know what 1 over x looks like, you might be able to graph e to the 1 over x by working with the graphs rather than numbers. That would be a good one to try. Maybe I should do that one tomorrow. I'll give you a chance to practice that. We'll see. Kind of like that idea. Yep. All right. So that was hopefully a little practice and coming at something from a slightly different perspective. And the more perspectives you have on an issue, the more you can analyze it. All right. Toodaloo.